Have you ever pondered over the science behind speed? Speed, it's a concept that's so deeply intertwined in our everyday lives that we often take it for granted. From the moment we wake up, it's there. It's in the alarm clock that jolts us awake, in the cars that whisk us off to work, even in the devices we're so glued to. But speed is more than just a measure of how fast something is moving. It's a fundamental principle in numerous scientific fields, from the physics that keeps our world spinning to the engineering that constructs our cities. It's the silent force that powers our world, whether it's the speed of light that allows us to see, or the speed of sound that lets us communicate. And yet it remains an enigma, a puzzle that scientists and researchers continue to unravel. So, let's embark on this journey together, shall we? Dive into the intriguing world of speed and its scientific implications. To understand speed, we first need to understand the basics. Speed, at its core, is a measure of how quickly something moves from one place to another. It's a concept that we engage with daily, whether we realize it or not. From the pace of our morning jog to the speed of our internet connection, speed is everywhere. But what exactly is speed? In scientific terms, speed is defined as the rate at which an object covers distance. It's a simple formula, really. Speed equals distance divided by time. So if you walk a mile in 15 minutes, your speed is 4 miles per hour. Imagine you're in a car, cruising down the highway. You glance at the speedometer and see it reads 60 miles per hour. What does this mean? It means that if you keep driving at that pace, you will cover 60 miles in 1 hour. However, there's a twist. Speed alone doesn't tell us the whole story. You see, speed is a scalar quantity, meaning it only has magnitude or size. It tells us how much, but not where. For that, we need to bring in another concept, velocity. Velocity, unlike speed, is a vector quantity. It includes both the speed of the object and its direction. So while your speed might be 60 miles per hour, your velocity will include that speed plus the direction you're heading, say, north. To put it simply, if speed is the how fast, then velocity is the how fast in which direction. And the difference between the two is crucial in understanding motion. But let's not complicate things too much. For now, let's stick to speed. You see, speed is not just about how fast you're moving. It's about the distance you cover in a given time. It's about the ground you can cover while racing against the clock. And understanding it can help us make sense of our world in a whole new way. So, speed is not just about how fast you go, but also the distance you cover in a given time. Speed is not just a simple concept, it's a cornerstone of physics. Let's delve deeper into this concept and unravel its mysteries. You see, speed is the rate at which an object changes its position. It's a fundamental concept that helps us understand the laws of motion. But here's the thing about speed. It's relative. It changes depending on the observer. Imagine you're on a train reading a book. To you, the book is stationary. But to someone standing on the platform as your train whizzes by, the book is moving at the same speed as the train. This idea of relative speed is crucial in understanding motion because it tells us that there's no such thing as absolute speed. Everything is moving relative to something else. Even as you sit still, you're moving because our planet is spinning on its axis and orbiting the sun. Now, let's talk about the speed of light, a mind-boggling 300,000 kilometers per second. It's the fastest speed in the universe, the cosmic speed limit, if you will. Nothing can travel faster than light. This isn't just a random rule, it's a fundamental law of nature borne out by Einstein's theory of relativity. The speed of light is so important because it helps us understand how we perceive the universe. When we look at stars, we're not seeing them as they are right now, but as they were when their light left them. So in a sense, looking at stars is like looking back in time. And here's another interesting tidbit. As you approach the speed of light, time slows down. This is known as time dilation, another mind-bending concept from the theory of relativity. It means that if you could travel at the speed of light, time would stand still. In the realm of physics, speed is more than just a number. It's a measure of how we perceive the world around us. So next time you're in a hurry, remember, speed is not just about getting from point A to point B. It's about understanding the very nature of our universe. From race cars to rockets, speed plays a crucial role in many human endeavors. It's a fundamental element in the world of sports, where athletes push their limits to shave off milliseconds, leading to breathtaking finishes. In transportation, the need for speed has driven incredible advancements. From the invention of the wheel to the development of supersonic jets, our quest to move faster has shaped our civilization. Speed is also integral to technology. The rapid transmission of information across the globe relies on the speed of light, the universe's ultimate speed limit. From fiber optics to quantum computing, our understanding and manipulation of speed have revolutionized the way we communicate and process information. But speed isn't just about going fast. It's also about precision, efficiency, and control. Whether it's coordinating a team of athletes or navigating a spacecraft, speed is often the difference between success and failure. So, from the racetrack to outer space, speed shapes the world we live in. With science and technology constantly evolving, the future of speed holds endless possibilities. Imagine a world where travel from one continent to another takes mere minutes, or data transfer occurs at the speed of thought. That's the kind of future we're looking at. As technology advances, we're likely to see incredible strides in speed. Quantum computing could revolutionize data processing, while hypersonic travel might shrink our world even further. However, these advancements aren't without their challenges. There are still many technical hurdles to overcome, not to mention the ethical considerations. How do we ensure safety in an era of hypersonic travel? What are the implications of near instantaneous data transfer? These are questions we must grapple with as we continue to push the boundaries of what's possible. But one thing is certain: the pursuit of speed, of faster and more efficient ways to move and communicate, is not slowing down. As we continue to push the boundaries of speed, who knows what the future might hold? So, we've taken a whirlwind tour of the science of speed. We've cracked the enigma, broken it down, and delved into the physics. In practice, we've seen how speed influences our world and considered its future implications. From the fundamental laws of motion to the cutting-edge technologies pushing boundaries, it's clear that speed isn't just about moving quickly. It's a fascinating, complex science that shapes our everyday lives. Next time you find yourself in a rush, remember, there's a whole lot of science behind the speed.